Welcome to the webinar series about BHC21, Boosting Human Capital in the 21st Century. And this is an Interreg 2 SEAS project which gathers the expertise of 12 partners from Belgium, France and the UK. And in this webinar, we will discuss the findings of our partners in regards to the innovative learning technologies that were used during the training programs. The first challenge, we found young people to join the program. And then it's up to training them and adding some innovative learning technology. So I have a question for you at home. Who already has some experience with innovative learning technologies in learning programs? And what technology intrigues you the most? You can type in your answer in the chat, and then we will have a look at the end of this session. So that brings us to technology. And technology innovation, it comes in many forms, and what seems innovative for me might not seem innovative for you, and vice versa. So I'm wondering, a very quick round of questions, what technologies did you use throughout this project? And I'm going to start with you, Alan. What did you use?
Well, we used several things. We used some video instruction tools to teach things like turning and milling, and we did some assessment. We had an assessment tool, but the most important thing was we used VR, virtual reality, to teach welding, and that was a big part of the program. Because, and the reason why we did that was because the area where we were operating, there are lots of small companies, small and medium-sized companies, and they have a real big demand for welders. So we thought this was a local need. The college, Mid-Kent College, where we work in, had already shown an interest in this and has started to develop it. So we grew that. So VR welding was a very important part of the program for us.
Cool. That makes me want to be a welder someday. How about you, Tineke?
Well, at the VDAB, we developed three things. We developed VR training, we developed an e-learning, and we developed a video instruction. It wasn't our plan in the first place. All behind this project, there was QLAC University, who did some questionnaires with people and who watched which tools would work the best. And what we saw in the first questionnaire with the group, the target group, which didn't use any technologies, is that they have difficulties when they have a piece of paper before them with an instruction on it or with a kind of flow they need to follow to put that in reality on the machine. The first thing we would thought is, well, like we would develop an IKEA model. You know, you have a closet of IKEA, you get a book with it, and then you know how to make the closet. That was our first idea to do here. But since the university found out that that wasn't the best thing to do with those target groups, we quit that idea and went on to the e-learning. Also, for VR, at first we wanted to do augmented reality because we thought if people go to the company afterwards, they even can get the support with the AR. If they are on the machine in production, they can get that same support there. But in the training center, we had a problem. We only have one machine. Before COVID, now we have like 8 to 10 students in training center. If you have to train them all on the same one machine and you have to give them a lot of practice, it takes time to have them. We have a training session of 10 days, which is very short. So if we want to give the low-skilled people enough of practice, we said we have to find some way to have an extra machine. And the extra machine is now in the virtual reality.
So it seems like VR is quite popular, so I'm going to take a wild guess, Mathieu, you also did something in VR.
Sorry, Matthias, but no. No, our colleagues at CETIM, which is a research and innovation center supported by the branch of mechanic industry in France, they wanted to develop a technology specific for the sector of machining, usinage in French, because it's one of the industrial sector in France that has the most difficulty to recruit people at the moment. And they wanted to focus on a technology that emphasizes learning by doing, and that is compatible with real work on the machine in the SMEs. which is not the case by VR. Finally, we have opted for a training technology using voice and video assistance. It was developed by an engineering company, Speaks Industry, especially for the project. And basically, it's working in 3 or 4 phases. First phase, the trainee is helped by the tablet. You're using a Padlet, a tablet. And the assistant, the voice assistant, is very present, very verbal. It gives a lot of instructions. So automatically it tells to the learner what action to do, what action to take. So after that, the second phase, the trainee is a bit more self-confident, is able to take some distance with the machine, and then the voice assistant is not so present. It only gives the key actions to follow, and then it prepares the phase 3, during which the learner is supposed to be quite independent from the Padlet, from the machine. Then the voice assistant is not anymore present, and there are some video instructions which can be activated on the Padlet by the learner, but it chooses to activate them or not.
Okay.
And of course, the 4th phase is the complete autonomy in front of the machine. So at the end of the process, the learner is not supposed to use the voice assistant anymore.
Nice. So we have some kind of simulation, we have VR, but I can imagine that choosing the right technology was rather tough because not every technology is suited for every problem. How did you tackle that, Tineke?
Yeah. We tackled it by having the university behind us, but we also tackled it by making a decision tool. This decision tool is actually available for everyone on our website. It has 17 questions from how many budget do you have, how many time do you have, what kind of skills do you want to train, etc. And it gives you, in the end, it gives you a ranking of a top 5 technology, which might help you in tackling those challenges. The most important thing about the tool is it helps you to reflect as a company on not just buying an expensive tool because, wow, VR is very popular and let's do something with VR because that's going to attract people. No, it helps you to look at your target group and to choose the right technology you need.
Okay. So I hear the word expensive. So then I think about return on investment and impact. Did you do anything about that? Were there any data that supports the choosing of the right learning technology?
The lessons we learned actually is one, to define and narrow down your question. You can put a whole training program in a VR, but is that really the thing you need? We tried, Bart, the instructor of the training where we focused on, helped us a lot to see where the most problems were in the training. Where do the low-skilled people struggle on? Where did they actually need help? And by narrowing it down, it helps you to get a clear focus on what to train and what to choose. And so we took only one part of the machine into the VR. We also found out that all the 3 technologies which we worked with are all very valuable, but in their own way. Like VR helps them to practice more and to see it in the reality in a safe environment, not having to be having to be scared that they will hurt themselves on the machine when they go on it for the first time. The online training helps them when they get the theory in the class to go through it again on their own pace and to see, okay, do I get it? Make an exercise on it. Do I understand the words which are needed? Put them in the right place. And then the video training helped Bart a lot because there are a lot of details when operating on a machine. But when you're with a group of 8 people around it, you not everybody sees the same thing. So when he shows the video in the class together, he can focus on, okay, this detail is important, this detail is important. So they see more details. For us, it was, I said it before, because of Bart, we narrowed down the question, but I think it's a valuable lesson for every company, everyone who wants to use with technology. Involve your instructors, involve your trainers. They have very valuable information on the target group, very valuable information on the training. So it's very useful to have them there. Do some evaluations with the trainer, with people who don't know anything about the industry, but put them in the VR, let them try it and see, does it work, doesn't it work? Also we asked the target group, what do you feel about it? Is it valuable for you? Does it motivate you or not? So those are lessons learned. And as for impact, it has had an impact in different ways, but also in ways we didn't expect. For us, VR was like, the young people will be motivated to use the VR. Yes, finally some attraction point to get them to the training. When we speak word to word, we will talk about it. We can use VR in that training, and more people will come. But we saw actually that in the first place, the low-skilled people were discouraged by using the VR. And that's because they get confronted with their own skills. When you're on a machine and you work with two people, there's always a stronger one and someone who follows. Now they had to do it all by themselves. So in the first place, when they entered the VR tool, they were like, I cannot do this, or I didn't understand quite, what do I need to do? So they got a little discouraged. That's also why Bart changed the whole process and introduced the VR from the beginning of the training and went through it step by step during the training. And actually, when they go through the whole process in the end, they actually get more motivated because then they can say, I did it all by myself. This is like really a positive thing I did. I can do this. Also, like the VR tools, you get additional insights. It's more extra information they get. So they have, and because they saw it once, they really remember it because they saw it visually. Also, the largest impact which we wanted was to reduce the training. Actually, we didn't succeed in that. The 10 days training actually became 6 to 8 weeks training now.
Okay.
Why? Because we saw that low-skilled people is a large variety of people. You have people who have already had careers in different sectors, who have experience. You have people who don't know Dutch as a language to follow the training. So the whole variety of people makes it extra hard also for the trainer and for the trainee to have like only 10 days to get the focus on, I need to do this technology, the vocational training, I need to get this. You need to work with them more on, give them time to repeat for some people. And if some people are like motivated or have other skills from other jobs, the trainer actually could give them extras like electricity or mechanics in the same training. So that's why we extended the training, so the trainer can be more like a coach and can put more variety into it, but at the end of the process, everybody can go to the labor market. So everybody on its own level can enter actually in a company.
Okay. Valuable lessons that you didn't anticipate it before you started, I guess.
Yes.
I have a question for you, Mathieu. You were talking about the step-by-step process with the assistance and the simulation. It seems like a very powerful training tool. But what is the biggest advantage of using the technologies that you used?
I think that all these digital simulations finally are only the virtual translation of a very, very old pedagogical principle, which is learning by doing. It's as old as the pedagogy. Yeah. So, of course, VR or 3D simulations give an additional dimensions, which is the fun. But it also exists when you organize something in the nature with young people and they have to find by themselves some leaves or stones. Yeah. The challenge is to design simulations that are as close as possible to the reality and which reproduce as faithfully as possible the conditions of a workstation, which is the most difficulty for the technicians, without being as critical as a poorly designed flight simulator. You can imagine the consequences of a poorly designed flight simulator for the training of the flight pilots. We can also imagine the consequences of learning to handle a machine in VR with a VR simulation which is too simplified. Even in the case of maybe a less fun technique, which is our voice and video simulation used in France, it's clear that it has accelerated the learning process. It's the first few weeks with the support of the voice assistant gave confidence, and quickly young people tried to escape from the machine, from the voice assistant. Yeah. So it gave them the autonomy, maybe, yeah, or the input and the self-confidence. As also we discussed with the coordinator of this training activity for cette, Kevin Tiberi, he told me that for us, this technique was not only a training process, but also a capitalization process, because the scenario of the voice assistant is co-built with the SMEs and the engineer and trainers in the SMEs. So it's also a way to capitalize the technical process, like a memory of the know-how in the companies. So it's also a dimension that we did not anticipate, but which was precious for us at the end.
Okay. And I'm sorry, Alan, the toughest question is for you. I said earlier I wanted to be a welder hearing the VR story, but if I'm honest, I don't think that you can be a welder just by going through some kind of a VR experience. I think there is a big... still a big thing to add instructor-led training to that VR experience. Do you agree with me, or do you have another opinion?
Partly agree. Instruction is really important, and of course all of the instructors were excellent from the college, so that was good. What we found was the VR was a slightly different experience, perhaps, to what I've heard, is that we found that the students were really quite motivated by using the VR. It overcame their fear. And you've got to remember, many of the people that we have on the course as we recruited, low-skilled people, unemployed, many of them have perhaps had bad experiences of learning. And added to that, going into a welding bay is quite an intimidating experience. So this was very good for, firstly, overcoming their fear of the welding bay, overcoming their fear of learning, that they could have a go using the VR. And they also made it fun because they introduced a sort of competition element, so who could score, who could get the best weld, because it comes up with a percentage figure and all this kind of thing. So that was quite good. It introduced a bit of competition, a bit of fun, with prizes of chocolate and whatever, so that was good fun. And that was quite motivational, as well as overcoming their fear, so that was good. But when I said partly agree, because it's not enough just to do the VR. They have to, at some point, do the real thing. And I think that the combination of the two is quite important to get that right, timing it and getting the combination of the VR and the real thing. So that was important. We found we had 4 cohorts, but one of the groups we actually divided them to try a sort of control group. So half the group did the VR welding before they went into the welding bay, and the other half went straight into the welding bay. And we sort of noted the difference. And we found that the group that used the VR welding, when they got into the welding bay, they progressed a lot quicker. And they felt more comfortable. They'd already overcome their fears. They'd had a go at doing some welds already. So they progressed a lot quicker. So it accelerated their learning, as Matthew said. So that's what we found. So partly agree that you still, of course, need the instructor, you need the real thing, but the VR really helps and accelerates that process. So